crazy with what we have to set up. And anyway, let me get rid of this before I forget it. All right. We have a 200 gram object that's loaded onto a spring that has a spring constant of 500 newtons per meter. The spring's compressed 5 centimeters and then released. I want the force of the spring initially. I want the maximum, or I want the speed at the launch point. And that one's not as easy on this one as what we think it is. And I want the highest point the object will reach above the original position of the object. Okay. Most of your problems, I'm going to give you mass spring systems that are horizontal. That makes it a ton easier. When we get to vertical, we have an extra thing to think about. Yes, it's going up and down, so I've got to factor in gravity. Okay? And it's not hard, it's just tricky because you have to think about, remember, gravitational potentials are arbitrary. It's based on where we assign 0. Okay? Because I can assign any point 0. But if I assign this right here as my 0 point, I'm initially starting with negative gravitational potential because I'm starting below that. So the best thing to do is always start, your lowest point in your problem is 0 meters. That's usually the best thing that you can do to simplify these. Okay? Good so far? All right. So let's get force of the spring solved for it. So I gave you all the information. Force equals kx. 500 newtons per meter times my compression distance of 0.05, and that gives me 25 newtons. Everyone okay with that? All right, what if I wanted the instantaneous acceleration of this? I didn't ask for it, but I will later, so I wanted to talk about it real quick. We can use Newton's second law, but remember in our lab that we did last Friday, I asked you to draw a free body diagram. We hung the weight on the spring. And you drew the free body diagram of being the spring force here and mg down, right? Are they equal anymore? No. Now you have that. So how do I write the equation for that?
Minus mg.
There you go. So if I wanted the instantaneous acceleration, that's the way I would solve it. What's the acceleration of the object the instant it leaves the spring? Come on now. Yeah, it's a projectile. Negative 9.8. So the acceleration is going to range from whatever this number is to negative 9.8. It's not going to 0. Does that make sense? Like I said, it's harder than what it looks because you got to factor in all those things. Okay, so let's talk about this next one. Speed at the launch. If we establish this as the 0 meter position right there, where's all the energy at? In the spring. Start off with a conservation of energy statement. At the launch point, where's the energy at? I had to work against gravity. think about this, and you can use a little common sense to think about this. Let's say I had a big, massive spring here on the floor, and I compressed it down, and then I put you on top of it. Okay, and then I released it. Now, then let's say we do the same thing, but I attach the spring to the wall, and I compress it and sit you in front of it, and let's say the floor is frictionless. Will you be launched at the same speed in those two scenarios? No. You're going to go faster when it's launched horizontally because all of the spring energy is going into your kinetic.
That's not good.
Do it. Whereas going vertical, some of that spring energy is going to the gravitational as well. Okay? All right, so let's finish solving this. 1/2 kx squared equals mgh squared. There's our equation. What's the height for this problem? Yeah, 0.05. There's 0.05 difference between there and there.
Oh, this is not come off.
You're all right. Got to activate the other brain cell, right? Are you plugging it in? Hurry up. I can't remember what the answer is, and I didn't write it down earlier. I got a crappy calculator today, so. One three.
I got two.
What's wrong with it?
Yeah.
Holy cow, 2.3. See if I ever have you do that again. Okay, one last one to go. This is the easy one. Highest point above the launch. Initially, the energy's in the spring, and how fast is it moving at the highest point? It's not. So all the energy at the highest point is in gravity. So getting the velocity at the highest point is going to be, or sorry, the highest point, not the velocity, but the highest point, just set your gravity equal to your spring. Okay? So 1/2 kx squared equals mgh. Now our h's are not the same as the x. Okay? And that's what we're solving for. So 1/2 times 500 times 0.05 squared equals 0.2 times 9.8 times h. Oops. What do you get? 0.319, is that right? Okay. 0.32 meters. So 32 centimeters. Make sense? Pretty easy. All right, so you guys got lots of time. You have an assignment due on Wednesday. No time in class tomorrow, most likely. So my goal for you is to have at minimum the first page done. And if we're really good, we got 20 minutes. Let's see if we can knock it out. Okay? I'll be around to help.